We talked about nuclear fission, which is splitting of a nuclei. Nuclear fusion is the combination, two lighter nuclei fusing together to become a heavier one. So both of these nuclear processes are highly exothermic because the daughter nuclides that are formed have greater binding energy per nucleon. Fusion is the source of energy for the stars, including our sun, and it is the basis of the hydrogen bomb, which is different than the atomic bomb. So the hydrogen bomb is about 1,000 times more explosive in force than an atomic bomb. So atomic bombs are what we dropped on Japan, and they caused a tremendous amount of damage and death. Atomic bomb is even more powerful. Okay. I just dropped my Apple Pencil again. Still works. Okay. So in a hydrogen bomb, we have two isotopes of hydrogen combining to form a helium nucleus. So deuterium is hydrogen 2. So the deut is the prefix for 2, deuterium, hydrogen 2, tritium, tri means 3, hydrogen 3. It's hydrogen 2 because the mass number is 2. It has 1 proton and 1 neutron. And in hydrogen 3, tritium has 1 proton and 2 neutrons. And so these two isotopes combine and form a helium nucleus and emit 1 neutron. So in order to detonate a fusion bomb, an atomic bomb, hydrogen bomb, it's not confusing at all. In order to detonate a hydrogen bomb, you actually have to use a small atomic bomb to get it started, because this needs to happen at extremely high temperatures. So it actually takes another bomb to get this bomb started. Nuclear fusion has been highly investigated as a power source. It would be really, really awesome. It is more energy dense than fission, so more energy with less fuel, and there are fewer problematic products. We don't get spent radioactive fuel, radioactive material that just is going to hang around for years and years and years and years that you have to dispose of or store somewhere, because you're just getting helium. So that would be great. The problem is that fusion occurs at extremely high temperatures, and there is no material known of that can withstand those extreme temperatures. So how do you contain this nuclear reaction so that you can harness its energy and generate power? The high temperature produces a plasma, which is the fourth state of matter that we generally don't talk about in Gen Chem. But that's a state of matter in which some of the atoms are ionized. One way this can be contained is a tokamak fusion reactor, and this uses coils to generate magnetic fields, and the magnetic fields can withstand the temperatures needed to enable the fusion to happen. So this can be done, but it's not economically feasible or practical yet. Hopefully, someday we'll get there. Any questions? This section really is pretty skimpy, if you ask me. So nuclear fusion is what's occurring in the sun, which is the source of the energy for our planet. So the sun is extremely hot, and hydrogen is being turned into helium. There's a I don't know if you've ever heard of a band called They Might Be Giants. They sing some really awesome science songs. The sun is a massive incandescent gas, a gigantic nuclear furnace, nuclear inferno, where hydrogen is turned into helium at temperatures of millions of degrees. It's a great song.